So, we live in a world full of incredible technological marvels, right? But there's this one huge promise from the past that, just hasn't shown up yet. Today, we're going to dig into one of the biggest questions in tech and evolution. Why can we video chat with anyone on the planet, but we still can't get a robot to reliably do our laundry? Our story starts in a pretty strange place, with a cartoon. Back in 1962, The Jetsons came out, and it was set a whole century in the future. And what's wild is that a lot of what looked like total fantasy back then turned out to be, well, a bunch of shockingly accurate predictions. I mean, just look at how much they nailed. Video calls? Check. Flat screen TVs? Yep. Smartwatches? Even a kind of 3D printing. All of this was totally unbelievable in the 60s, and now it's just part of our everyday lives. But there was one huge prediction that still stuck in the world of science fiction: the awesome, autonomous robot maid Rosie. And that brings us right to our central mystery. What did we get so wrong about how intelligence actually works? Why are the things we figured would be easy, like a robot just walking around a house, still so incredibly hard? To figure this out, we've got to follow the clues. So our first clue basically flips everything we thought we knew about what's easy and what's hard for a machine. We assumed the really tough challenges for AI would be the stuff that's hard for us, like high-level abstract thinking. It turns out we were dead wrong. See, early AI pioneers thought things like logic, math, and chess were the absolute peak of intelligence. But as researcher Rodney Brooks pointed out, evolution tells a totally different story. It took billions of years for life to perfect the basics, just sensing the world and moving around in it. All that abstract logic stuff, that was just a little add-on at the very end. The real challenge for AI isn't beating a grandmaster at chess, it's loading a dishwasher without breaking all the plates. And that basic physical skill is built on something called reinforcement learning. It's a really simple but incredibly powerful idea. You learn by doing. If an action leads to a good outcome, you're more likely to do it again. If it's a bad outcome, you avoid it. This is the ancient software that evolution spent billions of years writing, from the first single cells all the way up to us. Okay, but simple trial and error can only get you so far. To get us closer to a Rosie-level intelligence, we needed another huge breakthrough. Our second clue is all about moving from just reacting to the world to actually understanding it. Now, this next idea is a little wild, but it's key to the next big leap in intelligence. Your brain isn't just a passive camera recording what's out there. No, it's actively building a model of the world, a simulation. And then it just checks that simulation against the little bits of data coming from your senses. So, in a very real way, you're pretty much hallucinating your reality all the time. And the hardware running this whole simulation, that's your neocortex. You can think of it as this powerful what-if engine that's constantly trying to predict and explain what you're sensing. It's not just seeing raw data, it's figuring out the real-world things that are causing that data. And having this inner world is a total game changer. It lets us break free from just living in the present moment. We can think about the past by simulating what we could have done differently. We can plan for the future by simulating what might happen. This is the huge leap from simple reaction to complex, genuine reasoning. All right, so we've got reinforcement learning and we've got an internal simulation engine. That gets us pretty far up the intelligence ladder, maybe to the level of other smart animals like dolphins or chimps. But what was it that launched humans into a completely different league? Our third and final clue reveals our species' unique superpower. The real game changer wasn't just having a simulation running in our heads, it was figuring out how to transfer those simulations to other people's heads. And that's exactly what language is. It's a technology for swapping our ideas and plans directly from one brain to another. It's like a collective mind melt. And the effect is just world-changing. Language lets us create and share fictions, things like money, laws, or nations. These common myths only exist in our shared imagination, but they let us cooperate in huge, flexible groups, way beyond the limits of any other animal on the planet. And this ability to share ideas gives us the ultimate cheat code: cumulative culture. A single person doesn't have to reinvent sewn clothing from scratch. We get to build on top of a giant pyramid of previous inventions: sharp tools, dried hides, bone needles. This is how complexity just explodes, taking us from campfires to rocket ships over generations. Okay, so we've got our clues, we have the basic sensory motor skills, an internal world model, and then language to share those models. Now let's put it all together and finally solve the mystery. Why do we have things like ChatGPT, but we still don't have Rosie the robot? And here it is, the heart of the matter. Large language models are absolute masters of our third clue, language. They are unbelievably good at predicting patterns in text. But they are completely missing the second clue. They are essentially words without a world. They don't have an internal simulation of reality that gives those words actual meaning. Let me show you what this looks like with a classic brain teaser. Now, the fast pattern matching part of your brain probably jumps straight to 10 cents, right? But that's the trap. To get the right answer, you have to slow down, ignore that first instinct, and actually simulate the problem in your head. An early model like GPT-3 fell for the exact same trap. It gave the intuitive but totally wrong answer. But then look at GPT-4. It gets it right. So did it suddenly develop an inner world? Did it suddenly understand what a bat and a ball are? Well, not exactly. And here's the crucial difference. GPT-4 hasn't learned to simulate bats and balls. What it has learned from reading billions of pages of text is the pattern of how humans explain how to solve this exact type of problem. It's mastered the linguistic pattern of reasoning itself. It is an incredible mimic of understanding, but without the actual underlying simulation. And that brings us to our final thought. Let's zoom out for a second. Way out. See this number? 7 billion. That's the estimated number of years our sun has left before it dies. It really puts our little moment here and the entire 4 billion year history of life on Earth into a vast cosmic perspective. The point is, we aren't at the end of the story of intelligence. We're really just at the beginning. The journey from simple molecules to complex minds took 4 billion years. With 7 billion more years to go, and with these powerful new tools we're building, what comes next isn't an endpoint, it's a launch pad. What kind of intelligence, biological or maybe artificial, is just waiting to be born? It's a question that leaves us right at the dawn of a whole new era.